So our focus today is using the Pythagorean Theorem. This week we'll talk about how we can use it to determine whether triangles are right triangles or not. Today our focus is just to find the measure of the hypotenuse. Any guesses as to what in the world a hypotenuse is? No, it's not. Good guess. It has to do with the right angle of a triangle. Very good. It's associated with that right angle in the right triangle. There you go. It's the longest side in a right triangle, which is opposite the right angle. So we'll talk about that in just a bit. So we're going to start with our notes. What is a right triangle? I know you know this, but we'll just jot this in really quickly. A right triangle is a triangle that has a 90-degree angle in it. Oftentimes, you're going to see that little square because in the corner where our right angle is, because all of the angles inside of a square are 90-degree angles. So there's a fill-in for you. That is 90 degrees. Well, all right triangles can be looked at with the Pythagorean Theorem to give you the lengths of either leg, which we'll talk about tomorrow, or the hypotenuse, which we'll talk about today. So they're going to give you the measure of both of those legs, and we'll talk about what is a leg and what is a hypotenuse, and we're going to use the formula, the Pythagorean Theorem, to find that missing measure. So a little bit of algebra today. The two sides that make up the right angle are called the legs. So look for the right angle and those sides adjacent to it that help form the right angle are your legs in your right triangle. And then here's that word that we talked about a little while ago. The side opposite the right angle is called the hypotenuse. And because the right angle is going to be the biggest angle in a triangle, because it's half of 180 degrees, and 180 degrees make up a triangle, it's also going to be the longest side. And the way I remember that is leg, the word leg is smaller than the word hypotenuse. So the legs are going to be smaller than the hypotenuse. Just a few fill-ins with that. I'm never going to ask you how to spell hypotenuse, but it's always good to know. Maybe we'll in a spelling bee. Maybe we'll have a math spelling bee. Okay. So here is the Pythagorean Theorem, which is our focus for today. In a right triangle, if A and B, and we'll talk about what the variables A and B will identify in the right triangle. If A and B are the measures of the legs, and C is the hypotenuse, then here's that famous formula. A squared, so you take the measure of A, which is the measure of a leg, which they will give you today, and you'll square it, plus the other leg, which we will call B, and we will square it. The sum of A squared plus B squared in a right triangle is going to be equal to C squared, or the measure of the hypotenuse squared. And I was always one of those students I wanted to know why or how. So you don't have this next little portion in your notes. It's just kind of going to give us a talking point to look at this a little bit further. After this special note, the hypotenuse C is always the longest side. Hypotenuse is the longest word. When you're looking at legs and hypotenuse, it is also the longest side. It is also opposite the right angle. So if you can find the right angle, trace your little eyes to the opposite of that right angle, that is your hypotenuse, which is going to be C in our formula. So you don't have this. This is just for your viewing pleasure. Byrana, can you hit the lights, please? So here we have a triangle with the lengths of each of the three sides. So we know it's a right triangle. Well, we don't know because they didn't identify it. But here's our right angle. They're kind of telling you it's well, they're not telling you it's a right triangle. We will assume it's a right triangle. These two sides will be our legs. 5 would be our hypotenuse. Let's take a look at each of the lengths of the legs. So remember this bottom one was 3 units. So here I am taking those 3 units and I'm squaring it. So this is a square that is 3 units across and 3 units down. I can do that with the other side that is 4 units in length. And I've just turned that into a square. So who are my mathematicians out there, and you can tell me what 3 squared is equal to? Just tell me 3 squared or 3 times 3 is 9. 4 squared or 4 times 4 is 16. The Pythagorean theorem says, well, this side, which we'll look at in just a bit, should be 9, which is 3 squared, plus 16. What's 9 plus 16? 25. What's 5 squared? 25. So, that's why the Pythagorean theorem works. Because I can take the 2 shorter sides, square them, add those products together, and always, if it's a right triangle, come up with that long side squared. And then we've already talked about this. So we have 9 plus 16, that gives us 25. And this proves that the Pythagorean theorem does indeed work. So we're going to take, let me grab my little, see if this will let me grab my ink pen. You let me grab it. There we are. Make it yellow. So this was 3. The length of this side in our triangle was 4. The length of this side of our triangle was 5. And then our Pythagorean theorem says, well, I can take this side, square it, this side, square it, add the 2 together, and that will always give me this side squared. Notice how the sum of the 2 smaller squares equal the larger. And this is how it will work for every right triangle. So the 2 legs, and the legs are the shorter sides, when you square them, they're always going to give you and add them together, they're always going to give you an answer that is equal to the square of the hypotenuse. And that's where that A plus B plus C, A squared plus B squared plus C squared comes from. This, I think you do have in your notes. Can you turn the lights back on for me, please, so you guys can see? So the Pythagorean theorem, let me turn a sound off, or down, rather. Is A squared plus B squared equals C squared. Which of these variables represent the hypotenuse? A, B, or C? Do you remember? Actually, it's C. Many of you said C. A and B, they're sister letters. They come before C in the alphabet. Just like the word leg has fewer letters than hypotenuse. It's going to come before, dropping that thing. It's going to come before the hypotenuse in this formula. So the hypotenuse is always going to be what C represents. And once you figured out which is C, does it matter which leg you make A and B? What do you think? Are we gonna kind of stress out over, ooh, I know what C is. Ooh, is it A or is it B? When you're adding, does it matter which order you add? No. So which property says it doesn't matter which order you add? The commutative. So because it doesn't matter which order you add, then it really doesn't matter which side you make A or which side you make B. So no, it doesn't matter. Please stop making that noise. So here are our steps. Now we're getting into how do I solve for C. Nice to see pencils in your hand because this is probably the most writing you'll do all day in math. Step 1, write the formula. What's our formula? I should see more than one hand. What's the formula? You just wrote it down a few slides back. Caleb.
A squared plus B squared equals C squared.
You got it. Shout out to Caleb on the World Wide Web. And Paige and Janai and others have their hands up. Whoops, I'm on the wrong slide. Okay, so here's our formula. Oops. Sorry guys, I'm on the wrong. Step 2, substitute known values for the variables. So they're going to give you A, the value for A, the number that represents the length of A. They're going to give you B. You're going to solve for C. And then solve for the missing variable. Today, it's going to be the hypotenuse that we're solving for. Tomorrow, we're going to look at what happens when you're missing A or B. All right, so let's practice. So now we're getting into the practice part, and you have, I think, 1, 2, 5, 7 that we're going to look at, and then we'll practice this on our own. I still see pencils moving, so I'll give you some time. Okay, so you have a big picture of this triangle, and then on the next slide, next to that, you should have where I'm going to have all of it on the same slide. You have it on 2 different slides. Just want you to know that going into it. So how do we solve for the hypotenuse? Well, you take the 2 measures you do have. By the way, 8 feet is going to represent A. 15 feet is going to represent B. What's C going to represent? X, or our hypotenuse. So first we start off by writing the formula. That's our A squared plus B squared equals C squared. Step 2, which we just wrote down these steps, we're going to substitute or plug in the lengths of the legs, which in this case are going to be 8 and 15. So A squared is going to become 8 squared. B squared is going to become 15 squared. We don't know what C is. That's what our X represents, so we're going to solve for that. Now you're going to grab your calculator if you need to, and we're going to square 8 and square 15. What's 8 squared? 64. Awesome. What's 15 squared? Good job. 225. So we're going to take 64 plus 225 to find their sum. What's 64 plus 225? Does anybody have that yet? Who said that? 289. But that's not your answer because 289 is C squared. We just want to solve for C. What's the opposite of a number squared? Who can tell me that? Trevor, maybe you can tell me this because you did it in your mathetizer today. What button did you hit to get your answer? That looks like a check mark or square root. So the opposite of a square, which is what we have, is the square root. So we're going to put our little square root symbol over both of those numbers. And what's the square root of 289? 17. 17 is our measure for C. That's it, guys. That's what we're doing today. For the next few examples, the next six examples, and then for your homework.